Hi, today we've got a different mission. We've been approached by some amateurs who have asked the question, how tough are ferrites? If you drop one and it cracks and you glue it back together again, does it matter? If you've got one in a balun and you've been transmitting a bit too much power and you've cooked the wires around the balun and it's gotten very, very hot, has it somehow been reduced in efficiency? Can you use the same core again, or do you have to throw it away? These are interesting questions, so let's go and put it to the test. We'll pick one of these ferrites, measure its performance here on a spectrum analyzer, record the details, then we can do some terrible things to it and see how well it recovers. First we'll heat it up to a high temperature and see if that makes any difference. Then we'll break it into a few different pieces, put it back together again and give it a final test. Maybe we'll find that we have to throw it away, or maybe it'll be fine. So let's do the experiment. From this pile we've got a lot of different ferrites to choose from. I won't use one of the large ones because if the experiment fails I don't want to have destroyed it unnecessarily. We'll go with a medium-sized one. The effects are scalable, so it shouldn't really matter which one we select as long as we do the before and after test. This one looks pretty good. So we've got our medium-sized ring. This is the spectrum analyzer we've used in other videos and it's set up to scan between roughly 0 and 250 megahertz. We've got a normalized line which represents the resistance of the wire between these 2 points. We'll put the ferrite ring on there, measure its profile and see what it's like. Just a single turn is sufficient. Alright, we've got a characteristic curve. We've now saved this profile to memory. You can see that I've set a marker here at the very lowest point, which happens to coincide with 50 megahertz. And at that point, we have an attenuation of minus 2.53 dB. We'll be looking for that figure again after we've done our experiments. One of the fastest ways to heat up ferrite is to put it into a microwave oven, where it absorbs RF energy and heats up really fast. I wouldn't recommend you do this at home. I'm using an old 500 watt microwave oven, so if something happens to it, it won't really matter very much. To help us film this experiment, I'm going to use this handheld thermal imaging camera and a GoPro unit that are locked together so that I can film the ferrite as it heats up and have a look at it in normal video at the same time. The thermal camera shows the temperature of objects quite clearly. I can put my hand up here and it tells me that my hand's around about 33 degrees, something like that at the moment. Okay, let's see what happens. Right, let's see what we've got here. $170 degrees. Okay, that's cooled down quite a lot now. So we've given it a good baking at 170 degrees and we'll see what it does on the spectrum analyzer now. We're back in the test area. We got this ferrite, we put it in the microwave oven and we baked it for about 2 minutes. It seemed to get up to about 170 degrees C and no more, but that's still pretty hot. I think that in the real world, if you were getting 170 degrees C on your ferrites for a while, it would be melting the insulation off the wires. We'll put it back on the analyzer and see if it had any effect. Okay, it looks about the same as before. The frequency of maximum absorption is still at 50 megahertz. The amount of attenuation at that frequency is about the same. It looks like heating it up didn't make much of a difference here. It passed the first step okay. We'll move on to the second stage where we find out how it survives from physical impact. Moving right along, we're up to the next test where we take the ferrite ring and see if we can break it and then glue it back together again without losing any of its effectiveness. But I don't want to lose any of the parts, so I'm going to put it inside the Ziploc bag. Okay, now we find out how fragile it really is. That was pretty fragile. That looks a bit like some of the ferrite rings that have arrived in the post. We dropped it onto the concrete and it's fallen into about 4 pieces. Let's see if we can put it back together again. That went well. Okay, I've got my super glue, I've got my broken ferrite. Now to try and put it back together again. That went together quite well. We were fortunate when it broke that it was a fairly smooth break on each side. Now for the final step. Put it on the analyzer and see if it still works. There we go. Maybe the maximum attenuation frequency has shifted up by about 2 meg, but it's very, very little. The actual amount of attenuation, minus 2.4 dB, is very close to the original. You can see from this image, when we compare the original ferrite profile to after the repair, that the absorption of RF energy across the spectrum is about the same. That's a very interesting outcome. Even the point where it has the maximum attenuation is practically the same within a couple of megahertz. Let's take it off now. I wasn't sure how it was going to turn out, so what are the conclusions we have? We baked it in a microwave oven for a couple of minutes at least 150 degrees C, and that didn't seem to bother it much. Then we broke it into pieces, glued back together again, and it's come up fairly well from that too. This is telling us if it's experienced some physical damage, broken up into a few parts, but you glue it back together again, then you haven't actually changed the ability of the ferrite to absorb the RF energy. It's still there and it's still working. You can use it again. And that's something to take away from this exercise. If one day you find that you have overheated a balun, or you've ordered a ferrite from overseas and it's arrived in parts, then yes, you can glue it back together again and you'll probably get away with it. If you do work with some ferrites and do some repairs and want to share that experience, send your story to feedback@QRM.guru and maybe we can add your story to our website.